In this issue of Spacecraft Guide, we are going back into the Spacecraft Interactive Virtual Museum and to show you how to fly the shuttle. And this episode, we are going to go into the computer modes of the primary flight display and how those are shown to the astronauts. And when you go into the primary flight display, you end up at the primary flight display page, and you can see all these these topics up here, these two on the top left and these two on the top right. That's telling us where the computer and the software is, and we're going to do specifically this one on the top right, the major mode, hence MM, major mode status display. And when you click on that, it takes us to the major mode status display page, as you can see right here. And what this does is it displays the major mode status, and the status here is 103. That 103 is going to be important, so remember that number. The status indicators will change depending on the phase of flight to show appropriate data. At the top right status indicator field always displays the major mode. So this is always going to be where the computer software is in relation to the spacecraft, and that's very important. Now, the first things that we're going to go over that are very important is if an abort, and if an abort has been declared, an indicator will be displayed immediately to the right of the major mode. It'll be R for return to launch site, which this can get very hairy. T for transoceanic abort landing, CA for contingency aborts, AOA for abort once around, and ATO abort to orbit. Now we're going to go more into this into these aborts later, but if you are a subscriber to the podcast 16 Sunsets, they have an excellent episode on aborts entitled Abort, 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 and they go over all of these in depth with astronauts and instructors, and it's really, really good. I suggest that you all go to 16 Sunsets and listen to that. It will astound you at what the astronauts had to do. Now, besides the aborts, we get back here, the mode will depend on the phase of flight, those being ascent, entry, and orbit. And of course, the aborts goes with the ascent. So if you are a paying or a free subscriber to my Patreon page, and if you're not, what are you waiting for? It's free. All you have to do is sign up. Then just showing that you support me for free, we will go into the schematics here on how all of this works. So if you are a free subscriber and you click on schematics, you'll go here to the orbital flight computer software diagram. And here you see the orbital flight software, computer software goes to the application software, which comes to the guidance, navigation, and communications section of the application software. And then you can see the branches here on this side. And here we have Ops 9, which is for the pre, post landing, and configuration monitor. Now this is all the work prior to taking off, where it really starts where the MM starts coming in as the operations 1 here at ascent. So the major mode, if you see MM 101, that is a terminal count. So that's talking about getting ready for taking off. And just remember when I was talking about the numbers, that's what these numbers relate to. Instead of spelling the whole thing out, remember on the Apollo computer when we went over that it was explaining that each computer code, what they put in was a number. Well, this is the carrying through. So this carries over from the Apollo program when they put it in the computer. The Apollo was the first one to do that and start up computer programs with a definite name that were in an electronic database. So then the next one we have is the first stage. Then we have the second stage, which is 103. And as we see, ironically, well, not ironically, but that is this one here. We're in major mode 103. So that's what the primary flight display is going to most likely look at. And as you can see, it totally makes sense because here is the horizon. You're upside down on your back. The roll is 180 degrees. The pitch is 16 and y is 0, so that means there's no yaw. So that's what it will look like, and you see they're going through 160,000 feet, and you're going at over 2,000 feet per minute, 2,105, I think that's per second, but that's your h dot, which is your vertical velocity. And then here we have our alpha, which is our angle of attack, which is at 1.7, and 5.332 is your vertical velocity or your Mach number. But here it's not showing Mach, it's showing your speed. So 5.32 thousand feet miles an hour is how fast you're going. So if we go back and we look past 103, we have OMS1 insertion, and then OMS2 insertion, and then insertion coast. Now then it breaks off on second stage here for RTLS, which is return to landing site, then return to landing site second stage, glide return to landing site 1, and glide for return to landing site 2. Now all of these here, these have been explained to me, and if you listen to 16 Sunsets, as sporty. So you really want to listen to that podcast. And this will really, really catch your interest when they start talking about it. So now we've gone into orbit, and we're in Ops 2 here on orbit, and we see we have orbit coast, and maneuver execution is all in here. That's 201 and 202. Ops 8 is on orbit checkout when you're coming back down to land. So on orbit checkout is 801. And then entry, which we have 301 for pre-deorbit coast. That is getting the configuration, your attitude correct to decelerate and enter the atmosphere. Then deorbit execute, which that's deorbit is again going through the atmosphere, and again this is when the H double dot, when you have to watch your acceleration coming in, otherwise either you'll skip off the atmosphere or you burn up coming down. Then you have the pre-entry monitor, where this is all in hypersonic, so you're slowing down from Mach 25 to landing, so you the role of the spacecraft will be the only thing you'll be using to control the spacecraft, and it's very interesting on how that role works. We explained that earlier before with our hypersonic in previous issues. Then finally the entry into the atmosphere, and then the TAEM and landing is 305. So that is all the schematics that we have. Now, if you are a paying subscriber, and again, that's $4 a month, which is less than a cup of coffee for a month of my explanation here. And if you are a paying subscriber to the Patreon page and you click on schematic,